Okay, I am going to try to do the video on subqueries, which didn't get done in class the other day. Hopefully you can hear me. I'm not going to type in all of the code. What I did is I went to GitHub and I just copied the sample code from the chapter. So I am going to look at the different parts and explain them briefly, and hopefully this will help. So the first thing we did were subqueries in the where clause. And we were looking at the fact that you can't figure out who exactly is the person who gave the highest donation in a normal join. But you can if in the where clause you add a subquery. Select max donation amount from donation. If I were to run that just by itself, it will give me the maximum donation, $10,000. But I want to see who gave the largest donation. So I'm going to run this whole query. I have to select it all properly. And you'll see that it was little Scott who gave that donation. So the secret is where the donation amount is equal to the subquery, select max donation amount from donation. Couple of things about such a query in the where clause. It must return only one value. If there's any chance that it could return multiple values, it'll throw an error. So this is one of the uses of a subquery. You can use it to return a value that you can't get to in the normal select. So let's look at, this is the I'm not sure why that's there, the second one, but let's go to this one. This is to show you that you can do similar to what an inner join does. And this uses the keyword in. So we're selecting the person first name and last name from person where the person key is in, and then we do a subquery. Select person key from employee where employee key in, and then we do another subquery, select employee key from grant view. So what we're looking for are the employees that were involved in reviewing grants. In is a keyword that returns, that will look in a set. And if the value of the person key from the first query is in the subset returned by the second subquery, then it will match it. And then each one, it looks to see if they are in the subset. In allows the subquery to return a multiple, unlike the equal sign or the greater than or less than sign. In looks for through a subset to see if there are matches. It's important that you match like to like, person key to person key, employee key to employee key. It's just like the join. You're basically showing how the tables relate to each other. So when I run this, we'll see that it returns the name of 3 employees who have done grant reviews. Okay, you could get there with a join as well, and maybe a join would be a better way, but this is one of the ways that you can relate tables, is with subqueries in the in clause. Here's another use of that, which is actually very nice. This is the same as an outer join. So I'm looking for all of the grant types that are not in the grant application table. So these 2, travel and funerary, have never been requested. It's exactly the same as an outer join, except that I think it's even more intuitive than an outer join. Okay, so let's look at real quickly at subqueries in the select clause. This first one doesn't have any subqueries in it. It is just a query with aggregates that shows you how much money, and what the average. So this is like the total and then the subtotal for each grant type. So for childcare in 2018, there were 20 $2,050, and the average request was $256. Dental was $1,500, and the average was $300. That was the total, and the average was $300. So it goes through and gives for each one of those the total and the average, grouped by the type. So what I'm going to do next time is I'm going to add a grand total, right? This is the subtotal. We're going to add a grand total. We want to see what the total was for the whole year. So I'm going to bring that, if I get all of it here. Yeah, that looks like I've got it all. Notice that with this, the grand total is always the same. My numbers may be different than yours, by the way. Also, I was just looking at that. I'm not sure mine has the most current data, but the total is the same. Again, the subquery is different from the outer queries. It's not subject to the group bys. And this can be really useful. Sometimes you want to see not only the subtotal, but the grand total, especially if you want to calculate like a percentage, which would be the subtotal divided by the total. So this next one does that. It adds the percentage calculation into there. Okay, so here we have the percent, and I'm going to stretch that out so you can see. This is a 16%, 12%, 12%. It shows you what percent each grant got of the total. Now, to see that calculation, we have select sum grant application amount. That one is actually, let's go up a little higher. What we have is sum grant application amount. That's subject to the group by. That'll be grouped by each of the grant types. But it's divided by the subquery. And the subquery is independent of the group buys, so it can be the whole amount. It can be that 12,350, and then it's times 100 to make it a percent. Okay, I hope that makes some sense. The code is here. It's all on GitHub. I may post it also on the blog. So the only thing that this adds to that is it adds some formatting to make it a little prettier. Right, so if you want to look at that, you can. But it's basically, these are select clauses in the, these are subqueries in the select clauses. I know this isn't as coherent as I would like. It's hard to talk when there's nobody around. All right, so those are a bit complicated looking, but they're really useful. Sorry, I've got allergies or something here. So let's look at subqueries in the from clause. These are basically queries of queries. So notice how this select first name, last name, donor date, and amount. And then it's from. And then in the subclause, we have another query. Select person name as first name, person last name as last name, donation date, donation amount as amount, from person, inner join on donation. So all the joining and all of that is done in the subquery. We do have to name the subquery. That's absolutely required. So here is the query. Okay, so we're querying a subquery. Notice it has first name, last name, donation date, and amount. Let's look at another table expression. In this one, we do a lot of the functions in the subquery. And then we can just select the aliases, select year, month, total. And then down here, we extract the year, we extract the month, we do the sum of the donation, we do our group bys. We've done all of that. The subquery is called as totals. This order by is based on the outer query. So we're ordering by year. And when I run that, oops. Oh, for some reason, this is missing a comma. And there that is. Month, so year, month, and then the total donated for that month. And this is the same thing, except we're doing where the year is greater than 5,000. The donations per year is greater than 5,000. And once again, it's missing that comma. I'm not sure how that happened. What is it not? Oh, semicolon. I'm going to have to go in there and fix these. There it goes. So those are table expressions. They're basically where they have a subquery in the from clause. And again, they're fairly useful because they allow you to query a query. So this is exactly the same thing, but it's structured differently. Let's see if I can get the whole thing on there. Maybe if I move this down a little bit. All right. This one we start with totals as. So we define what the name of the subquery is. The as means that the subquery is going to substitute, be the alias for totals, or totals will be the alias for it. So we select and we extract our year, extract our month, we create a sum, we do our group bys. All right. And then we select after we've defined the table. So we select year, month, and total from totals, where total is greater than 5,000. This will have exactly the same effect as the other one, except I didn't do the order by, but that's okay. The only difference is the way it's structured, and this is the preferred way to structure it because you define your subquery before you select from it. That way you know what the fields year, month, and total mean before you use them. So this is actually the preferred way to do it. It has essentially the same structure, but it's a little bit different. Now this shows some of the advantage of that. Back in the previous chapter in joins, we talked about how if you join the city with the donation, you get duplicates because some people have more than one address. This uses select distinct on, and on we can put a key value there on donor key, and it will look for distinct fields, look for distinct donation keys. As far as I know, other database management systems do not have that. But the effect of this is that it will give us the correct total. It'll ignore duplicates and it'll give us the correct total of loans. We do the query first in the with city donations as in order to eliminate those duplicates, and then we can sum them on the outer query and get the correct totals. All right, we're almost done. The last thing is a correlated subquery. All right, so this is this is not a correlated subquery. This one, if we run it, will give us all of the requests that are above the average, but it's above the total average. It's not paying attention to the type. So it's really comparing apples to oranges. Your food average, your request for food is mixed in with your request for rent. And those things are really not that comparable. So with this correlated subquery, you can solve that problem by comparing type to type. But to do it, what happens is that the inner query calls the outer query. Notice how I alias grant application as G1. And then I say where grant application amount is greater than, and I say select average grant amount, application amount from grant application, and I alias it G2. And then I provide a where clause where G1, which is the outer query, grant type key is equal to the inner query, G2, grant type key. This is basically a recursive function, but it does make it so you're not comparing oranges to oranges. I mean, you are comparing oranges to oranges. You're not comparing oranges to apples. So it compares, one is food. So it has two grant application amounts that are greater than the average in food. It has 4 that are greater than the average in rent, which is the second one. We could look at that. So let's do the second one. Let's do select average grant application amount. All right, from grant application. And we'll do the where grant application or grant type key is what we want. Okay, so we're going to look and see what the average one is for the grant type 2. Okay, so the average is, if we pull this all the way out, the average is 583. And if we run this and look at the 2s again, we can see that the number 2, they're all above 583. There's 600, 800, 800, and 1300. They're all greater than that average. And if you were to check the average for each type, you would see that that is the case. All right, so this is not very coherent or very energetic, but this is a quick review of what we did in class. I will post it, and I will also post the code. So I'm going to stop the video now.